Bismillahirrahmanirrahim. Dr. Mohammed Yousaf from the Department of Chemistry, Islamic College, Peshawar is here. Dear students, Assalamu alaikum. In continuation of the previous lecture on the reactivity of aldehyde and ketones, today we will talk about various reactions of aldehyde and ketone. The first reactions is reduction of aldehyde and ketone. Reduction of aldehyde and ketone. First, what is meant by a reduction? Reduction is either the addition of hydrogen, either in molecular form or in nascent form. Keep in mind, addition of hydrogen or removal of oxygen, that is called the reduction. So the first reaction which we will discuss is reduction of aldehyde and ketone. And as I have told you, it is either the addition of hydrogen or removal of oxygen from a compound. The first reaction is the reduction of these carbonyl compound into alkane. Reduction of carbonyl compound into alkane. That is how these compounds can be used for the preparation of alkane. Keep in mind, in organic chemistry, the most interesting point is that it is the property of one compound like aldehyde or ketone, it is the method of preparation of the other compound. So here reduction is the property of aldehyde and ketone, but here you see it is the method of preparation of alkane. So you can prepare alkane by the reduction of aldehyde and ketone. How? By two methods. Keep in mind, these are two important reactions. One is called Clemmensen reduction. And the second is the Wolff-Keshner reduction. These two reduction reactions, they are used for the preparation of aldehyde, for the preparation of alkane from aldehyde and ketone. Keep in mind, these are very important from MCQ point of view. But the two reactions, that is Clemmensen reduction and Wolff-Keshner reaction, they differ from each other in the nature of the reducing agent. Here, look over here. Here, zinc amalgam. What is amalgam? Amalgam means a solution of any metal with mercury. A solution of any metal with mercury is called amalgam. So in Clemmensen reduction, zinc amalgam and concentrated HCl are used as a reducing agent. This point should be kept in mind, that in Clemmensen reduction, which one is used as a reducing agent? Zinc amalgam and concentrated HCl is used as a reducing agent. This point should be kept in mind. But here in Wolff-Keshner reduction, hydrazine is used. This is hydrazine. Hydrazine is used as a reducing agent. These two reactions, that is Clemmensen reduction and Wolff-Keshner reduction, they differ from each other in the nature of the reducing agent. Here zinc amalgam and concentrated HCl is used as a reducing agent, while here hydrazine is used as a reducing agent. Remember, the mechanism of this reaction is highly complicated. It will take a very long time, and no need of explaining the mechanism of this reaction. It is not there in your text. So just keep in mind here that 4 hydrogen are utilized in this reaction. 4 hydrogen are utilized in this reaction. How? 2 hydrogen are added across the carbon oxygen double bond. This is one addition of hydrogen, which is called reduction, as I have told you. Two hydrogen are used in converting the carbon oxygen double bond into a single bond. So here two hydrogen are used and the double bond is converted into a single bond. And in the second step, two hydrogen are utilized in removing the oxygen from alcohol to give you alkane. And here it is ethane. So here the two processes are taking simultaneously. One is two hydrogens are added to this compound and two hydrogen are used to remove oxygen, and finally you get ethane. In volcational reduction, hydrazine is used as the reducing agent. Two hydrogens are utilized from here to remove this oxygen and give you water. This nitrogen become attached with this carbon with double bond, and here you get this compound. This compound is called alkyl hydrazone. And one of the entries test, it was asked which of the following is alkyl hydrazone. So keep in mind the formula of this alkyl hydrazone. This is alkyl hydrazone. Again, I will repeat, oxygen is removed from here, two hydrogen are removed from here. This nitrogen become double bonded with this carbon and you get this compound. This compound is called alkyl hydrazone. This alkyl hydrazone is then heated with KOH and boiling ethylene glycol. This is ethylene glycol. So boiling this compound, that is alkyl hydrazone, boiling this compound in KOH, that is ethylene glycol, we get alkane, and nitrogen is obtained over here. So the main reaction over here is the removal of this nitrogen from here and you get this nitrogen gas. So keep in mind, Clemmensen reduction and volcational reaction, they are used for the preparation of alkane from aldehyde and ketone. Do not waste your time on the mechanism of these two reactions. They are too much complicated. Therefore, you need not to study the mechanism of these reactions. Just keep in mind the nature of the reducing agent in both the reactions. In one case, zinc amalgam and concentrate HCl is used as a reducing agent, while in the other case, hydrazine is used as a reducing agent. The second reduction is reduction to alcohol. In this reduction, aldehyde can be converted into primary alcohol, while ketone can be converted into secondary alcohol using what? Lithium, aluminium, or sodium borohydride is the reducing agent. The mechanism of this reaction is quite different from the mechanism of these two reactions, that is Clemmensen reduction and volcational reaction. This reaction proceeds through hydride addition. Hydride, where this hydride come from? Either from lithium aluminum hydride or sodium borohydride. What is hydride? Hydride means hydrogen with negative charge. So that hydrogen is added over here, and the rest of the reaction is a bit complicated. You again need not to study the mechanism. Just keep in mind that aldehyde can be converted with lithium aluminum hydride or sodium borohydride to primary alcohol, while ketone can be reduced to secondary alcohol. The second reaction, that is reduction of aldehyde and ketone, involve nitrogen nucleophile. Nitrogen nucleophile is present where? In ammonia, ammonia and ammonia derivatives. These are derivatives. 2 से लेकर 5 तक ये मैंने derivatives लिए हैं. इन तमाम में नाइट्रोजन न्यूक्लियोफाइल इस्तेमाल होगा. अब लुक, ये एमोनिया है, एमोनिया. इसमें यहां पर मैं एक लाइन खींच रहा हूं. ये देखो, ये लाइन जो मैंने ड्रा किया, इसमें NH2 ग्रुप यहां पे तमाम में रह गया. ये यहां पर जिस तरह मैं क्लास में बताता हूं अक्सर, एक तीर से मैं 5 शिकार करूंगा. 1 2 3 4 5. Just understand one, you will understand the rest of the compound. Here you see nitrogen is having lone pair of electron. Here lone pair, lone pair, lone pair, lone pair. This is the attacking nucleophile. This is the attacking center. Keep in mind this, and this. All these are the attacking nucleophile. While this is the electrophilic portion of the group. Here hydrogen, 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 and hydrogen. Right? So these are the reactive groups in all these compounds. Once again, I may revise. Ammonia contain nitrogen is the attacking nucleophile, and the rest of the compounds are ammonia derivatives. How they are obtained? Hydrogen here is replaced by alkyl group. It is alkyl amine. It is replaced by hydroxyl group. It is hydroxylamine. It is hydrazine, this one, and this is phenylhydrazine. Phenylhydrazine is the derivative of hydrazine. Now look over here. Just try to understand only one reaction, and the rest of the reaction will become very easy. There will be no problem at all. Now here, try to understand what I am going here. Look over here. This nitrogen, it will attack over here, right? And this oxygen will attack on this hydrogen. I am just giving only one reaction, and the rest of the reaction you can do by yourself. Here, this carbonyl carbon, over here, this nitrogen become attached over here. So NH, OH. For simple reason, I have not shown the group attached over here and here. On this side, you may be having hydrogen, you may be having an alkyl group, and on this side, you may be having a phenyl group, alkyl group, or hydroxyl group. I don't talk about on this side. यहाँ पर इसकी जगह मैं G लगाता हूँ. G means any group. Any group means either this group, this group, this group, or this group. So let's write over here is G. While the other two groups, they are shown over here. They are shown over here. Not here. It should not be here. It should be here. It should be here. Because here, as you see, nitrogen is attached with the carbon, and one hydrogen is attached over here. So in the rest of the cases, in case of ammonia, it will be hydrogen here. But in the rest of the compound, it will be G, because one hydrogen has been added. This hydrogen has been added, nitrogen will be left with only one hydrogen. So this group may be, this group may be either or here, or HO, or NH2, or this group. तो ये आप लोगों के लिए बहुत ज्यादा आसान हो जाएगा. Just understand, in ammonia, nitrogen is the attacking nucleophile over here. One of the hydrogen become attached with oxygen, nitrogen become attached with the carbon, right? If it is ammonia, then this will be having two groups. Instead of this group, you will be having H, while in other like alkyl amines, hydroxylamine, hydrazine, it will be this group, or this group respectively. So यहाँ पर आप एक तीर से 5 शिकार कर सकते हैं. इन ग्रुप्स को छोड़ दें, सिर्फ ये वाला ग्रुप जो है इसको सेलेक्ट करते जाएं. ये यहाँ पे अटैक करेगा, इधर ये यहाँ अटैक करेगा, इधर ये अटैक करेगा, इधर ये अटैक करेगा, और बाकी हाइड्रोजन के बारे में मैंने आपको बता दिया कि इस हाइड्रोजन पर ऑक्सीजन अटैक करेगा, and you will get the respective intermediate. This respective intermediate. Now this respective intermediate will give the final product. How? In certain cases, OH will be removed from here, H will be removed from here. What you will get? You will get water. You will get what? Water. OH will be removed from here, H will be removed from here. You will get a double bond between carbon and nitrogen. ये G जो है, ये G, ये R भी हो सकता है, ये भी हो सकता है, ये भी हो सकता है, और ये भी हो सकता है. तो इसी मुनासिबत से, इसी G के मुनासिबत से आपके पास क्या हासिल होगा? अगर आपके पास आपने एमोनिया लिया है या अल्काइल एमाइन लिया है, you will get amines, IMINES, amines. अगर आपने हाइड्रोक्सिलामीन लिया है, you will get oxime. अगर आपने ये हाइड्रोजोन, अगर आपने ये लिया है, हाइड्रोजीन लिया है, you will get hydrazone. अगर आपने ये लिया है, you will get phenyl hydrazone, and so on. So once again, I will repeat because I have covered 2 pages just in a single paragraph. Therefore, if some of the students that faces difficulty, then once again I may repeat: reduction using nitrogen nucleophile. Nitrogen nucleophile is in ammonia and ammonia derivatives. Ammonia derivatives are those in which hydrogen has been replaced by alkyl group, by OH group, by NH2 group, or by phenyl group. This is alkyl amines, this is hydroxylamine, this is hydrazine, and this is phenyl hydrazine. The rest of the structure is exactly the same in all these compounds. Only this portion is different. So ignore this portion and just concentrate on this region. Here nitrogen is the attacking nucleophile. It will attack over here, and hydrogen will be attacked by oxygen. You will get this addition product, and this addition product may undergo elimination reaction. And this elimination reaction, what will be removed? OH will be removed from here, H will be removed from here, with the result that you will get a double bond between carbon and nitrogen. And that final product will depend upon the starting material. If you have taken these two, you will get amines or shed bases. If you have taken this one, you will get oxime. And if you have taken this, you will get hydrazone. If you have taken this one, you will get phenyl hydrazone, and so on. All these reactions, they are given on page number 276 up to 277. You should memorize all these reactions just in one line if you understand what is the attacking nucleophile and what is the positive portion. With this, I hope that you may have understood the reduction reaction of aldehyde and ketone, and inshallah in the next lecture I will talk about the reduction using carbon nucleophile and various oxidation reaction of the carbonyl compound. Thank you very much.